Hi friends, this is the second video of the series. Sorry, this video took too much delay while to start due to some personal reasons. So from this week onwards, you will be getting the videos continuously. So in the previous set, I had completed from question 1 to 16 of KSET 2020 Inorganic. Today, I will be continuing from 17 to 32 questions of Inorganic. In this, I use the simplest method. In some cases, they are directly concept-based questions which I will mention it. In cases with lengthy answers, I have not showed the calculation. I just shown the answers. In case if I get the easier way to solve it, then I'll share it as soon as possible. So now let's deal with question number 17. The aqueous solution of MnH2O 6 times 2 plus is light pink in color. The best reason that I can explain is here it involves DZ transition. So, but we have to tell which condition is allowed and which condition forbidden. Here, to understand this, let's draw a ground state structure of Mn plus. So here we will have this configuration where the total spin is 5 by 2. Since H2O is a weak field ligand, there will be no forcing. And if we give a transition, if we allow transition, we will get a total spin of 3 by 2. So since we know the selection rules, delta S should be equal to 0. But in this case, there is change in delta S. So it does not follow the spin. It should be spin forbidden. It will become spin forbidden automatically. And delta L is possible only if it is plus or minus 1. Means transition from D to D is with will give delta L is equal to 0. So it is both orbital forbidden, spin forbidden. So here option B is the correct answer. So in this case, choose a correct statement with reference to thorium and uranium. Thorium forms iodide of the type THI2, THI3, THI4. Second statement is in solid state salt of UO2 plus 2 contains linear cations. The reaction of sodium compound with this will give you this complex. So this is a direct concept based question, and it is expected that you should know all the possible reactions and possible compounds of the compound. In this case, only first two are possible, whereas in this case we don't get monolinear, we get a complex like chain. For this reason, this statement is not possible. Now in the next question, we have to find a total valence electron in this complex. So to calculate total valence electron, we have to identify the number of electrons given by, or we have to find the valence electrons of each. Here I have taken from each element. Since there are 2 molecules of hydrogen, 2 into number of electrons plus 3 into ruthenium plus 8 into CO because it is a complex, and plus 2 of mu pH2. Since when we say mu, it will be having sharing. So we have to see how much it gives in sharing. So hydrogen will give 1 electron, ruthenium has 8, CO has 2, and in this mu sharing will get 3. So total 48 electrons. This is directly based on the number of valence electrons present. In case if you are not sure, make sure you have to know what are the valence electrons present for each atom and ligands, and if they are having sharing, bridging like conditions. So here option B is the right answer. So similarly, now they asked us to find in this question total number of metal bonds present in this complex. Here there is a general formula to find the total number of metal bonds can be given as 18 into n, where n refers to number of metals and total valence electron. In the previous question, I have shown how to find a total valence electron. So here I have directly taken it. I have shown here the calculation, that is 4 into 9, because we have 9 atoms. So 4 into 9 plus 12 into 2. So it comes to 16. Here when we take this calculation, we get 6. So this indicates that there are 6 metal bond. So with the next question, oxidation reaction, addition of H hydrogen bond, carbon hydrogen bond, carbon bonding with the metal complexes. So I just shown the reaction over here. Here you can take AB as hydrogen or carbon or carbon. So what you all know, whenever say oxidative addition means there should be change in the the metal oxidation state. So here I've shown, if it is binding with some ligand where metal has zero oxidation state, it will only form a tree center where it continues to contain the new oxidation state of the previous complex. After getting oxidated edited, you will get 2 as charge. So here you will get 3 center pathway. Now, okay, next question is species containing quadrupole bonds or delta bond. Whenever we study, we'll only study of sigma pi. Delta bond means you should have 4 bonds. Here there are conditions whenever you want to find it, you should know that the metals such as molybdenum, chromium, technetium, tungsten, ruthenium, these metals with ligands such as pi donors, this should be typically pi donor, then only you will get the quadrupole bonds. Not necessarily, it is not necessary that only these. There may be some exceptions with pi acceptors, but more typically we'll get for pi donors. Here this one is a pi acceptor. This one has both pi acceptor and pi donor. This is purely pi acceptor, where here we again have pi donors and pi acceptors. So option B is the correct answer. Now according to Wade's rule, the structure type of B5H9 is. So whenever we have to find this, it's easier way to find this. Number of boron atoms you have to consider. Here we have B5. So split the hydrogen in such a way that 5 plus something, N plus this. Here we have 9. So 5 plus 4. If you write it in state of power, you will get it 5 B5H5 raised to 4 minus. Means general form BnHn4 minus. So since it's given that if you have minus 2, BnH2 and minus 2, it's closo. BnHn4 minus is nido. BnHn6 minus is archino. And BnHn with 8 minus is hypo. Here it is 4 minus and it's matching with the basics requirement. So this is nido. For this question, I could not get a simpler way to solve it. It has a lengthy procedure to get the answer. And according to that, the answer comes at 38. I'm trying to get a simpler method to explain this question. As soon as I get it, I'll try to share. But in case if I fail to get it, I'll give the lengthy way of solving this problem. So next question is, the constant current of 0.8 ampere is used to deposit copper at the cathode and oxygen at anode of electrolytic cell. The numbers of moles of copper and oxygen deposited in 15.2 minutes respectively is. Here they have given the Faraday's constant and what is the reaction taking place. So here first thing is we have to convert this 15.2 minutes into seconds. That comes to 912 seconds. And 0.8 ampere can be written as 0.8 coulombs per second. And to get the total charge flowing, we'll get it 0.8 into 912. This comes to 729.6 coulombs. So the formula is very simple. If you understand this part, you can easily do this. So number of moles is equal to the total charge flowing into the electrons involved into Faraday constant. So in case of number of moles of copper, we have 729.6, which you get over here, divided by 2, because here the charge is reduced from plus 2 to 0 into Faraday's constant, which is given by them. In case if it is not given, then you have to see the nearest simplified version, 96,500. Here they have given 96,485. That is the exact value. But in case they are not given, take this as 96,500. It will be easier for us to calculate. So this on calculating we will get a 3.798 into 10 to the power of minus 3. Similarly, when you take of oxygen, here the number of electrons involved is 4. So you will be, instead of dividing by 2, you will have to divide by 4. That comes to 1.89 into 10 to the power of minus 3, for which your answer 3 and D will match. In some cases, they will ask us to find the amount. So whatever we get the moles, multiply it by atomic mass. In case of copper, multiply by 63.5. In case of oxygen, multiply by 32. because it is O2, not O. That will give us a total amount. But since they asked us in moles, so this will be sufficient. So let's go to next question. Here there are many metal enzyme catalyzed reactions. So we have to identify the metal enzymes possible atoms ions present in it. So in this case I have directly written what are the possible reactions, because individually if you try to find out it will be difficult. So this reaction corresponds to chlorophyll. This reaction will be observed in presence of isomerase. This is peroxidase and this is cytochrome P450. For this chlorophyll will have Mn, that is manganese. Isomerase is cobalt. In case of peroxidase and cytochrome P450, we'll get iron. So option B is the correct. For this question and the next question, you can refer the Bioinorganic Chemistry by A.K. Das. We'll get the exact answer for this. So the key factor in Perescu mechanism is, here I'll directly mark it because it is expected that you have to understand the concept about hemoglobin and how it works. So the A.K. Das book for Bioinorganic Chemistry has explained this in proper way. So please refer that book. It will be easy for you all. So now next is H1 and 31P NMR spectra for pH3, where 31P has 100% abundance and it has a value of I as nuclear spin as half. So now we have to find for H1, 1H NMR and 31P NMR. For finding the number of peaks, we have the general formula 2 into Ni plus 1, where N refers to number of atoms and I refers to nuclear spin. In H1 NMR, the nuclear spin is half, because some of the elements you should compulsory know the nuclear spin. In some cases, if the nuclear spin will be given if it is more other than half, but if it is not half also, you should be aware of some basic nuclear atoms and what are the spins. So here I am taking for 1H NMR. So since it is 2 into 1, because here it is based on P. P is having effect on it. So into half plus 1. So we will get a doublet. And in case of 31P NMR, we'll have 3 electrons. Means hydrogen is giving effect on phosphorus. So we'll get a quadrat. So for this answer is a doublet and a quadrat. Doublet refers to 1H NMR and 31P NMR will get a quadrat in the peaks. So in this one you may get some other elements where I value need not be known, or if they give 2H means the I value will be 1. So for some of the elements, common elements with their which isomer has which I value, you should be aware of. I'm not expecting you to remember each and every one, but considerably you have to remember some of this. Now spin selection rules for electronic, means that is allowed transition and NMR spectra. This is a direct concept based question. It is expected that you should remember this as standard rules. In previous smaller standards, you are expected to know the tables from 1 to 15 or 20. Similarly, if you are trying to study for chemistry, there are some selection rules, some basic rules that you have to remember. Otherwise, it will be difficult to answer such kind of direct scoring questions. So now these are the last 3 questions. Here you have a nuclear reaction. Nuclear reaction, only you have to balance the powers, either it is subscript or superscript, and you will get the answer. Here we have 4, 27 and 1. Means you have to balance this out. That is 4 plus 27 is 31. Minus 1 is 30. So you will get 30. 2, 3, 13 is 15. Here is no other. So you have to get a compound where 30 and 15 should be there. Here what happens, 30 and 15. 15 is the atomic number. So atomic number 15 is sulfur. It is here they are given silicon. This cannot be the answer. Here they are given 31. As per the calculation we should get 30. So this is also not answer. Similarly, here they are given 31. 15P is phosphorus. It's correct. So this is actually can be correct answer, but here we have 31, so it will not match up. So option D is 1530p. Means here it is matching this condition and this. Okay, while writing I made a small mistake. This should be phosphor, not sulfur. Because sulfur is 16, it is phosphor. So option D is the correct answer. Now this the reaction between tetrachlorosilane and lithium aluminum hydride. This is a question based on P block and S block elements. Here I have directly given the reaction. In some case, some books will get it as lithium chloride plus aluminum chloride plus silane. Since we don't have that option present here, I assume that it will further react with and give the lithium aluminum chloride and silane. So the only possible option is silane and lithium trichloroaluminate. In some cases, they may give the direct name as lithium aluminum chloride, or in some cases they may give in the complex form, that is lithium trichloroaluminate. Aluminate is given only because it is having a negative charge. Now the next question, XPX bond in POX3, where X is chlorine, fluorine, bromine molecule is in the order. So this is the structure of the compound. So whenever you realize whenever two bulky groups are the nearby place, it will be difficult and they will be getting themselves far away from each other. Since we know that bromine has bigger size compared to others, the angle between them should be more compared to chlorine and compared to fluorine. Fluorine will be having the least angle because it's not so bulky, but the electronegativity will also have effect on it. So if we take the consideration, bromine in this case has a maximum, chlorine is slightly less, fluorine is much lesser. In this case, chlorine is given the least and fluorine is the maximum. This cannot be the answer. In this case, chlorine is given medium, but as we has given least, but it is expected by the pattern we have to have the minimum value, so it is not possible. In last case, chlorine they are given maximum, which is also not possible. So the only answer possible here is A. So in this, I have completed the inorganic section of 2022 KSET paper. If you all get any kind of difficulties, or if you all get any kind of issues, you can directly post it in the comment, or can contact me on my mail or the Instagram ID which I have given. Similar videos of organic will be posted within, I'll share it as soon as possible. So please do like my channel and subscribe it and share it among your friends. Thank you.